So in number 1, they have a string of numbers for us here. They have 3, and they've taken it and squared it. 3 squared is 9. Then they took 5, and they took it and squared it. 5 squared is 25. They took 11 and squared it. 11 squared is 121. 17 and squared it. 17 squared is 289. All of these numbers, the 3, the 5, the 11, and the 17, are all what type of number? These are all odd numbers. And when you take an odd number and square it, you multiply it by itself, the result was always what type of number? An odd number. What about on number 2? They're still taking and squaring things, but this time they're squaring what types of numbers? Even. 4, 8, 14, and 20. When you take an even number and square it, you're getting what type of number out? When you take an even number and square it, you're getting an even number back. So what you guys just did on this warm-up, go ahead and grab your books out for me. This leads us right into our conversation. We're going to start on page 153. What you just used is an example of inductive reasoning. Page 153. Inductive reasoning, the process of reaching a conclusion based on a pattern of examples. When you make the assumption that the pattern that you're observing is going to continue, you're applying inductive reasoning. You can use inductive reasoning to make educated guesses. We call the educated guess a conjecture. So inductive reasoning is when you look at a pattern and you think you can make a prediction about what's going to continue to happen. The prediction that you make, the educated guess that you make based on that pattern, we call a conjecture. I want to practice using your inductive reasoning and making these educated guesses, making these conjectures. I want to start with one that's not in the book. You wake up in the morning, you look outside, the sun is not shining, it's cloudy, it's gray outside. And off in the distance, you hear a rumbling noise. What would your educated guess be about that? It's gray, it's overcast, it's not sunny outside, and you hear rumbling noises in the distance. It's probably going to storm, it's probably going to rain, right? Is that a guarantee? No. But it's an educated guess based on what?
On the environment.
Based on the environment. Would everybody that is exposed to that same information reach the same conclusion? Would a 3-year-old reach the same conclusion that it's probably going to storm? Why not? They haven't had enough exposure to evidence. They haven't seen this pattern happen often enough. You guys have had repeated exposure to these same pieces of information, and oftentimes when it's gray, overcast, cloudy, it's not sunny out, and you hear that rumbling, that means that a storm is going to happen later because that's what you've witnessed happening over and over again. So the conjecture is, I better grab my umbrella, it's going to storm. That is your educated guess. The inductive reasoning is when you go, I've seen this pattern happen before. All right. So I want to practice that. Let's look at example number 1, still on page 153. So as we are making conjectures, the first thing that we're going to do is look for a pattern. That's our inductive reasoning there. So here we have these lists of times, 8:30, 9:15, 10 a.m., 10:45 a.m., and they've kind of drawn our attention to the pattern that's happening here. What pattern is happening between these numbers? What's happening each time to go from one time to the next time? They're adding 45 minutes. 8:30 plus another 45 minutes gets us to 9:15. 9:15 plus another 45 minutes gets us to 10 a.m. 10 a.m. plus another 45 minutes gets us to 10:45 a.m. So now we're going to make our conjecture. The pattern that we saw was that each appointment time is how many minutes after the previous one? 45 minutes. So that means the next appointment time is going to be 10:45 plus another 45 minutes. What's 45 minutes after 10:45 a.m.? 11:30 a.m. So the pattern that we saw was that each appointment time is 45 minutes after the previous one, and so our conjecture, the prediction that we're making, our educated guess, is that the next appointment time is going to be at 11:30. Are we guaranteed to be correct with that conjecture? No, for all we know, they leave for lunch at 11:30, and they wouldn't actually have an appointment then. Is it reasonable based on the pattern to make that assumption? Yes, so conjectures aren't guaranteed to be correct, but they should be based on the evidence that we have. All right, let's go down and look at the check at the bottom. Take about a minute and a half. I want you to look at this pattern of numbers. 1/2, 1, 2, 4. What kind of pattern do you see happening between the two? It should be a pattern that's repeating itself. What happens to the 1/2 to get the 1? What happens to the 1 to get the 2? What happens to the 2 to get the 4? When you think you've identified what that pattern is, I want you to write that down right here. The next number in the sequence is blank the preceding number. So what's happening to your numbers to get the next number? And then I want you to make a guess about what number comes after 4 in the pattern. So take about a minute or so. What's the pattern that you see? You're going to write that in this first blank. What's the next number in the pattern? You're going to write that on the second blank. What are they doing each time to get the next number in the pattern? Levi? They're doubling it. So the next number in the sequence is double the preceding number. And so you said the next number would be 8. 1/2, double it to get to 1. Take 1 and double it to get to 2. Take 2 and double it to get to 4. So continuing this pattern out, we would double 4 to get to 8. Or you could say 2 times. How you word it is not necessarily as important as what's that pattern that you're identifying. You could say that it's 2 times. You could say that it's doubling it. I can think of other possible ways that you could phrase this. But again, what pattern are you identifying? That's using your inductive reasoning. And then the educated guess that you make based on that, that is your conjecture. All right, let's flip the page. Go over to page 154 for me. Most of the time, unlike that appointments example, and unlike the warm-up that we did, we aren't provided with those examples. So if I wanted to make a conjecture about the sum means what? Adding. The sum of the squares of two consecutive numbers. What are consecutive numbers? What does it mean for them to be consecutive? What'd you say? Congruent? Not necessarily. Two, four, six, that would be consecutive even numbers. Two numbers that what? Not necessarily the same. You could do even consecutive numbers. Could you do consecutive counting numbers? Like what comes after 3? 4, those would be consecutive. What comes after 7? 8, those would be consecutive. So when we talk about consecutive numbers, we want numbers that are in order. So two numbers that come like one after the other. When they say natural numbers here, natural numbers, those are our counting numbers. So examples of consecutive numbers would be like 1 and 2. So I'm going to take those two numbers and I'm going to square them, and then I'm going to add those. So what's 1 squared? 1. I'm going to add that to 2 squared. What's 2 squared? 4. 1 plus 4 is 5. All right, two other consecutive numbers. You guys agree that 2 and 3 come one after the other when we're counting? All right, so we're going to take both of those numbers and square them, and then we're going to add them together. What's 2 squared again? 4. And 3 squared? So I'm going to add 4 and 9 together. What's 4 and 9 added together? 13. 6 and 7 are 6 and 7 consecutive. Yes, let's take those and square them. 6 squared? 36. 7 squared? 49. 36 plus 49. 36 and 49. Well, what's 6 and 9? 15. And then 4 plus 3, 85. All right, two more consecutive numbers. 10 and 11 are consecutive. All right, let's square those. 10 squared would be what? 100. What's 11 squared? 1. That's 121, and that was on our warm-up page too if you needed to double check. What is 100 plus 121? 221. Look at all these numbers that we got as the result. We took two numbers that followed each other in line, in counting order. We squared it, and then we added them both together. What types of numbers did we get back? Odd numbers. So we had a list of examples, then we looked for a pattern. We saw that the result was always an odd number. And so then we're going to make our conjecture. The sum of the squares of two consecutive natural numbers is an odd number. That is our educated guess. And you guys already told me that educated guesses aren't always true, right? Sometimes we make an educated guess and we're not right. We're going to talk later about how to test to see if our conjectures, to see if our educated guesses are true always or just true sometimes. We're not going to focus on that so much today. So far, so good? All right, I want you guys to look at the check right underneath this one. And I want you to make a conjecture. So the first thing we need to do, did they give us a list of examples to look at? So make a list of examples then. Our examples are going to be the sums of two odd numbers. So you need to pick out two odd numbers and add them together. Then do it again. Pick out two different odd numbers and add them together. Then pick out two different odd numbers and add them together. Make a list of examples. Then look for a pattern. And after you've made your examples and looked for a pattern, once you think you've identified that pattern, then make a conjecture. Everybody should be writing down their list of examples so that you can identify a pattern. You need a list of examples that would be the sum of two odd numbers. So again, pick out two odd numbers, add them together. See what you get. Nope, we're not squaring them. We're just adding two odd numbers. Any two odd numbers you want, but it needs to be two odd numbers. Damon, give me two odd numbers. 3 and 7. We're going to add those together. 3 plus 7 would give us what? 10. Francis, give me two different odd numbers. 5 and 13. What is 5 plus 13? 18. Leo, give me two other odd numbers. 3 and 5. We're going to add those together. 3 and 5 is what? 8. Mia, give me two other odd numbers. 9 plus 1. 9 plus 1 would give us 10. What kind of a pattern are we noticing when we add two odd numbers together? They're all even. So we saw our pattern, and then we used that to make our conjecture that the sum of two odd numbers is always an even number. Sum of two odd numbers is, that's our conjecture. Again, are we guaranteed that that's true? Is it possible that there's two odd numbers out there somewhere that when I add them together, I get another odd number? Like I said, we're going to practice later learning how to evaluate whether this statement is always true or whether it's just sometimes true. We're going to look for something called counterexamples. A counterexample, and we'll practice this tomorrow, but a counterexample is if you can find one situation where our conjecture does not hold true. So an example going back to the thunderstorm example. You hear a rumbling in the distance, you look outside, it's gray, overcast, the sun is not shining, but on that particular day, it doesn't actually rain where you are. That would be a counterexample. So then I would know that my conjecture that when I see these different things, when I hear these different pieces, it's always going to storm, I would know that that's not an always situation. We can make conjectures about geometric relationships. So here we've got some isosceles trapezoids. Isosceles trapezoids means these are trapezoids with two opposite congruent legs. So looking at this big trapezoid, these two legs over here are congruent. That's what it means for it to be isosceles. This little trapezoid down here, these two slanted legs are the same size as each other. This medium-sized trapezoid, it's these two slanted legs here. These are the same size as each other. They are congruent. When you look at these isosceles trapezoids and we connect these diagonal vertices, what looks to be true about these two diagonals, these segments that are joining opposite vertices? Do they look wildly different? How do they look? They're making an X shape, and you said they look to be the same. Could we grab a ruler and test that? Could we measure each of those diagonals? Yeah. We could use a ruler or a compass to measure those. But they appear to be the same size. So my conjecture would be that the segments joining opposite vertices, opposite corners, remember vertices are our turning points or our corners. Our conjecture is that they are always congruent, that they're always the same size. Top of page 155. We're supposed to make another conjecture about a geometry relationship. We're supposed to make a conjecture about the relationship between AD and AB. What does it mean if it doesn't have anything over the top? We've got two letters with nothing over the top of it. The length or the measurement, yes. So this would be the length of segment AD and the length of segment AB. So we need to look at both of these. We need to compare their lengths and look to see if there's some kind of relationship, some kind of pattern between these two. Do I have anything to look at? No. Then I'm going to need to draw this based on the information that they've given me. So they tell me right here that C is the midpoint of segment AB. So the first thing I'm going to do is draw that. So I'm going to draw a segment. What would the names of the endpoints be here? A and B. And what do I want to add to that picture? Point C. Where is point C? Midpoint, exactly in the middle. So what is point C doing to this whole segment then if it's the midpoint? It's cutting it exactly in half. It's splitting it exactly down the middle. So what would that mean about segment AC and segment CB? They are going to be congruent. So CA and CB would be opposite rays if we continued on forever, if we had arrows on this. But since C is the midpoint of this segment and it's cutting AB exactly in half, I know those two smaller pieces are going to be identical in size. Do they give me any more information here? What did they tell me? D is the midpoint of segment AC. So AC is this right here. Where is D going to be? Exactly in the middle of those. So right here. So what does that mean about AD and DC? AD and DC, these two little ones, those are congruent. So AD, this little piece, is the same size as DC, this little piece. Remember, we're supposed to make a conjecture about the length of segment AD. That would be this distance right here. And the length of segment AB. Well, what is AB? Is that one of the little pieces again? It's the whole thing. So from here all the way over to here. Think about this like a candy bar. If I have a candy bar, that's from A to B, that's the length of my whole candy bar, and I cut it exactly in half at C. I've got two halves of a candy bar that are exactly the same size, right? If I take one of those halves and I cut it exactly in half, what would the relationship be of that little piece to my whole original candy bar? It'd be a quarter of it. It would be 1/4 of it. So AD is 1/4 the size, 1/4 the measurement of that whole big long segment. Let's look at one last example and we'll call it a day. Example number 4. The table shows the average price of gasoline in the United States for the years 2010 through 2018. We want to make a conjecture about the price of gas in 2019, and we're going to explain how this conjecture is supported by the data given. So my first question is, as we look down the price per gallon, down the right side of the table, between 2010 and 2011, did the price of gas go up or down? Up. How much did it go up by? How much did it go up by? How much? Almost $1. Went up by 74 cents, almost $1. From 2011 to 2012, what happened to the price of gas? Went up, how much? 10 cents. Did the price go up again the next year? No, what happened to it? It went down 10 cents. From 2013 to 2014, did the price go up or down? Went down. How much did it go down by? How much? 14 cents. What about between 2014 and 2015? What happened to the price of gas? Went down again. How much did it go down by between 2014 and 2015? $1 and a penny. And then it went back up again? Then it did what? Went down again. How much did it go down by? What'd you say? Close. I think it's 39. Is it 39 or 29? 1, 3, 2, 3, 4. Yeah, 29 cents. You're right. Went down 29 cents. Between 2016 and 2017, what happened to the price? It went up. How much did it go up by? 28 cents. Between 2017 and 2018, it went up. How much did it go up by this time? 42 cents. And we are supposed to make a conjecture about what happened in 2019. So my first question before we come up with our conjecture, is it going up every single year? Is it going down every single year? No. So I want to come up with a conjecture and I want to base it on the evidence that I see. What's a pattern that you guys notice in those prices? Yes.
It goes down an even number.
It went down an even number of times. How many times did it go down? 4 times.
So
and then it started adding, right? So in 2019, do you think the price is going to go up or down? I've got some conjectures for down. I see a conjecture for up. I think we can write a conjecture for both of these. All right, I heard down first. So first conjecture. The price of gas in 2019 will decrease because, without the because, it's just a guess. It's not an educated guess. Price of gas in 2019 will decrease because. What pattern are you seeing to make you think that it's going to go down in 2019? What'd you say?
Every 2 years that the gas price goes up, it increases 4.
So it increases for 2 years and then it goes down for 4, and then increases for 2 and then goes down for 4. That's one of the patterns that Leo picked out here. It went up, up, then down, 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 then up, up. So maybe we're going to see down, 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 down again because the price increases for 2 years. And then increases for 4, or sorry, then decreases for 4. I think, based on the evidence, that that is a very valid conjecture. Is that the only possible conjecture that we could come up with here? Right. Sylvia, I see you saying no. What do you think the price of gas is going to do in 2019? Could also increase. So let's say the price of gas in 2019 will increase because, remember, just saying that it's going to increase or decrease, that's just a guess. To be a conjecture, it has to be an educated guess. So you need to give reasons for why you think that. All right, so Sylvia, since you made the claim that it's going to increase, tell me what you're seeing. Why do you think that?
Since we don't know what happened in 2009, like we don't know the price of the gas in 2009. We don't know if it increased or decreased.
So maybe it's increased 3 years, decrease 4, increase 3 years. Maybe it's even increase 4, decrease 4, increase 4, decrease 4. All right. So the price of gas in 2019 will increase because the pattern may be increase 3 years. Then decrease 4 years. Is this second conjecture guaranteed to be correct? Is the first conjecture guaranteed to be correct? These are both educated guesses, right? That are exactly opposite each other. So how would we know who's right? You'd have to wait. You got to wait and see. What happened in 2019? We'd have to wait until that year was over, and then we could look at the evidence and then decide who made the better guess. And then look at making a prediction for 2020. Maybe we go with the same conjecture that was right in 2019 and make that same educated guess again. We have to wait for the evidence in this particular situation to know which conjecture would be correct, but it's possible to have two conjectures, both based on evidence, that are absolutely opposite each other. All right, last thing we're going to do is the check down at the bottom of the page, and you guys are going to do this mostly on your own. This has to do with hearing loss. Almost half of young adults, people between the ages of 12 and 35 years old, are exposed to damaging levels of sound from the use of personal electronic devices. What do you think they mean by personal electronic devices? Earbuds, headphones. You put those on, it is your favorite song, you crank that up. I have blown speakers in my car doing this before. Being exposed to really, really high levels of sound, especially when it's trapped right here against your ears, can cause this hearing loss. The intensity of the sound and the time spent listening to a sound highly affects the amount of damage that can be done to someone's hearing. The intensity of the sound to the human ear is measured in A-weighted decibels, or dBA. Decibels is how we measure how intense sound is. For every 3 decibels over 85, the exposure time it takes to cause hearing damage is cut in half. So if you listen to music and it's at 85 decibels, you're not going to do any damage until you've been doing that for 8 hours solid. But if you crank that volume up a little bit at 88 decibels, now you could only go 4 hours listening to it at that volume before you start to cause hearing loss. I want you guys to make a prediction about how long you could listen to sound at 106 decibels and how long at 106 decibels before it would start to cause hearing loss. And I want you to give me your answer in minutes. Notice they give us this in hours. We're supposed to write it in minutes. So take about 2 minutes. I want you guys to try to figure out at 106 decibels how long until it causes damage. Good guess, though. I like that. What do you notice here as far as pattern goes?
It goes up by 3 every time.
It's going up by 3 every time, and I want you to take this out to what? I want you to take this out to how many decibels?
106.
106. So you said you saw a pattern of it going up by what each time?
3.
Up by 3 each time. Yes. Guys, put the phones away, please. This is a chance to practice what we're learning. This is not a time to be on your phones. What pattern do you see happening in the decibel level, the left-hand column? What's happening down that left-hand column? 85, 88, 91. Yes, dear. It's going up by 3 each time. So what would come on this table after 100? 103. And after that? 106. That's the one that we want to find, 106. So we have to extend this table out 2 places. Well, what's happening to the time? It's dividing by 2. It's cutting it in half. So we have 8 hours, then we have 4 hours, then 2 hours, then 1 hour, then a half an hour, then a fourth of an hour. What would come after a fourth of an hour if I'm cutting in half? 1/8, because we'd cut it in half. 1/2 of a fourth of it is an eighth. What happens if I cut that one in half? 1/16. But that's in hours, and I want this in minutes. So let's look at something that's already in minutes. Or sorry, already in hours that we can change into minutes. 1 hour is how many minutes? 60. If I cut that in half, that would be 30. What's half of 30? 15. What's half of 15? 7.5, 7.5. What's half of that? 3.75. So at 3.75 minutes, so less than 4 minutes, it would cause hearing loss at 106 decibels. Guys, that worksheet is your homework. It is due on Thursday. We still have tomorrow in class to work on stuff, and then that worksheet is due on Thursday. Have a fantastic rest of your day, everybody.